In this lecture, we will discuss some examples about Bayes formula. First, recall that Bayes formula basically says that you can express a probability of, say, set B as probability of B given A times probability of A plus probability of B given A complement times probability of A complement. So basically you write set B as A intersection B and then A complement intersection B. Also notice that you could write probability of B intersection A as probability of B given A times probability of A. This B intersection A is also A intersection B. So we are going to use these two results. So let us do our first example. So there is an online test that is designed to test mathematical ability. So 95% of the time it is effective in determining or detecting the ability if the person is in fact above average. So it will test correct. So person is above average, you give him the test, 95% of the time the test is effective. But 1% of the time it also gives false positive. It identifies a person with average or below average mathematical ability as above average. Only 0.5% of the population has above average mathematical ability. So we want to find that, say, a person shows a good score on the test, that is, he does well on the test, and the test says it is true that this person is above average mathematical ability. Then what is the probability that person is actually above average? So you fix B as test shows the person is above average, and A, person actually is above average. So we want to find out probability of A given B. That person has performed well on the test. Then what is the probability that he is actually above average? So you just put the conditional probability formula here. Now you use Bayes formula here and then this formula right here. So instead of A intersection B, you could say B intersection A. So probability of B given A is 95%. That is, the test shows the person is above average and it is given that the person is actually above average. So 95% of the time the test is effective. So you get 0.95. Probability of A that person actually is above average is 0.5%. So that will be, probability will be 0.005 divided by this, we have just written probability of B given A times probability of A, same. Probability of B given A complement. So that test shows that person is above average, but actually the person is below average. So the person is below average, but the test shows he's really well. So that is false positive. So that is 1% of the time it also gives false positive. It identifies a person with average or below average mathematical ability is above average. So you put as 0.01. So then times probability of A complement. The person is actually above average is only 0.5% probability. So 0.5% of the population has above average ability. So probability of A complement would be 1 minus 0.5, that is 99.5%. So this is 99.5%. And that's why you write 0.995 here. So you compute it, you get 0.323. So only 32% of the people whose test results are positive actually have the ability, according to our test, which has 95% effectiveness. Let us do another example. So suppose there is a multiple choice test with n alternatives. Now the student is taking a test. Now he either knows the answer with probability P or he guesses the answer with probability 1 minus P. So if you know the answer or you do not know the answer. So if you know the answer with probability P, you do not know the answer with probability 1 minus P. So if the student guesses the answer, it will be correct with the probability 1 by n, because say it's a multiple choice and say suppose n is 4, so that you will have 4 alternatives, A, B, C, D. So if the student does not know the answer, then he will guess any of the answer with probability 1 by 4. So he will guess the answer, and with probability 1 by 4, this answer will be, say, correct. So that is what we are writing. It will be correct with the probability 1 by n. So say B is the event that student answers the question correctly. A is the event student actually knows the answer. So we want to find out probability of A given B. That student has answered the question correctly. But what is the probability that he actually knows the answer? Because you could have just guessed it. So again, we use the same formula as before. So what is the probability of B given A? So student actually knows the answer and he answers it correctly. That is 1. So if he knows the answer, then he's going to answer it correctly with 1 times probability of A. Student actually knows the answer, so he knows the answer with probability P. So this is P. So this we have just computed from above. This will be 1 times P here. So you get P here, P here. So what is probability of A complement? That the student does not know the answer. So he does not know the answer with probability 1 minus P. So you have 1 minus P here. So probability of B given A complement, student answers the question correctly, but he does not actually know the answer. A complement is he does not know the answer, but he answers it correctly. So that probability is 1 by n. So he just picks up one alternative out of n, and that comes out to be correct. So that is 1 by n. So probability of A given B is np over 1 plus n minus 1 p. So for example, if your p was just half and say n was 4, then you can immediately see that your answer would be 1 over 1 plus 1 by 4, which will be 4 by 5. So there is a 80% probability or 80% chance that student who answers the question correctly actually knows the answer. So if you pick P as half and N as